Howdy Ags, my name is Aditi Mani, I'm in Chem 120 section 412, and today I'll be talking about how reaction rates have a dependency on temperature in my experiment called elephant's toothpaste. The elephant's toothpaste experiment is the rapid decomposition of hydrogen peroxide using activated yeast as a catalyst. Our experiment today will be testing the reaction rate's dependency on temperature through two types of yeast mixtures that will be added into the solution. So the solution itself is comprised of hydrogen peroxide and dish soap liquid, along with a couple drops of food coloring in order to just give it a colorful appearance. Now, the activated yeast mixture that will be added into the dish soap and hydrogen peroxide solution will be containing of activated yeast and a temperatured water. Now, in our case, we're going to be doing two temperatures of water. One will be lukewarm, and the other one will be colder temperatured water. This goes to show the reaction rate's dependency on temperature, as when the lukewarm yeast mixture is added into the dish soap hydrogen peroxide solution, it will react almost instantaneously, creating a foamy product. When the colder temperature yeast is added into the dish soap hydrogen peroxide solution, it won't react as fast as we hope, and therefore showing that reaction rates are dependent on temperature. Now, like any other experiment, we're going to be needing some safety equipment. So let's go ahead and get it on. First, let's get our aprons on. Sick. All right, next we got to go cover our feet. Now that we're all dressed, let's go ahead and start the experiment. These are all the things you're going to be needing for your experiment today. Now we're going to use a funnel just to keep the liquids from spilling everywhere else. We're going to use a 1/4 cup measuring cup and some hydrogen peroxide. Pour 2 1/4 cups of the hydrogen peroxide into your bottle, and then we're going to do 1 1/4 cup of dish soap. We're going to make our warm water for the experiment for our yeast mixture. So we're just going to put a mug of water into the microwave and warm it up for about 30 seconds. Take it out of the microwave, and we're going to make our yeast mixture. Take some yeast, a bowl, and a spoon, and pour in your yeast mixture first. Then pour in the water. And now we're just going to mix it up until it looks a little something like this. Now while we wait around 5 minutes for the yeast to activate, we're going to add in some red dye just to give it a little color, and you're going to swish it around the bottle to mix it all together. Now it's time to do our experiment. Take your yeast mixture, start your timer, and pour all the mixture into the bottle, and it will soon react. That's our time. Now we're just going to do it all over again, but with colder water. So you're going to add your 2 1/4 cups of hydrogen peroxide, your 1 1/4 cup of dish liquid, and now we're going to use colder water for our yeast mixture instead of the warmer one, like before. Open up your yeast packet and pour it into your bowl. Then add in your colder water. I just use a spoon to keep the ice from falling in. And now give it a good mix until it looks a little something like that. That's our setup, by the way. We're going to be using a phone as our timer, and we're going to start it as soon as we add in the mixture and stop it as soon as the reaction naturally occurs. That's the time we record it. So in conclusion, the yeast mixture that was warmer had a shorter reaction time than the yeast mixture that was in a colder temperature, thus showing that reaction rates are indeed dependent on temperature. Thanks, and giggle.